So in this video, we are going to learn how to insert a node in order statistics tree. So already we have discussed what is order statistics tree. This is the tree which is obtained by augmenting an RB tree. Already we have discussed in our previous videos. Okay, so now let's see how we can add a node into this augmented RB tree. So you can see on the screen, this is how it is represented. Every node is having a key value and also one extra field that is called size. So size basically represent how many nodes are there in overall tree. So if you look at the root node, the 26 value is the key value at this root and 20 is the size. That means it contains 20 node overall. In this tree, 20 node overall is there. So now let's see how the insertion can be obtained. So in order to start with insertion, we need to see that how the size field is maintained, because whenever you do insertion, the size at each field. Uh, so whenever you do insertion, the size field of each node is going to change. So actually, when we do rotation, rotation is a local property. So only two nodes are actually affected. So we do not need to worry about all the nodes which are there in the tree. So how we are going to maintain the size field? So already we discussed the algorithm that how to maintain this information of size in every field, that whenever you insert a node, we have to start from the root and we search for the position where the new node to be inserted, and all the node that occurs during the traverse is to be increased by size 1. And then we insert the node, and after inserting the node, we will see that the tree is stable or not. That means it maintains the arbitrary property or not. If it is not, we need to do rotation. And when we do rotation, then size is maintained by using this formula. This formula, you can say by this method, we are going to maintain the size. So what does it mean? So let us take this example. So we have any node which is having the key value and we have a size. So let's say this is node Y and this is node X and this is the size of Y, this is size of X. So we are going to do the right rotation. Then in that case, this node is going to come up and this node goes down. So it will be like this, X will go up and Y will go down. Then size of X will be the size of Y. So whatever the size of Y is having, it is this value is given to X. And what about this node which is going down? So we will look to the right subtree of X. So we will see what is the, so this is the, let's say, the size of right X, this is the size of right Y. So when this node goes down, the size of Y will be is equals to size of right X plus size of right Y plus 1. So this is how things are maintained. So you can see here, this is Y, this is X, and when we do the right rotation, this node goes up, 42 comes here, and this size becomes the size of this. And when this goes down, so the size of this node means Y, which comes down, will be size of this plus 1. So 4 plus 7 is equal to 11 plus 1, 12. Okay. So having understood how the size is to be maintained, let us do some operation. Let us take some insertion case. So this is the first example where we are going to insert a node with key value 15. So how it will work? This is arbitrary. So arbitrary is having colors in every node, but we have to insert in an order statistics tree. Okay, so this tree must have one field size also with every node. So let us also update this arbitrary with the size field. So this is 1, this is 1, 1 plus 1, 2, and this 3. So this is 1. So 3 plus 1, 4, and plus 1, 5. This is 1, this is 2, and 5 plus 2, 7, and this 8. Now we are going to insert node 15 with key value 15. So we start from here. So it works like this. We start from 9 and then it goes to 10 because 15 is more than 9, so we have to go to right subtree, and then again 15 is more than 10, we go to again right subtree, and then again we have to move right. So this is the position to insert 15 here. Okay, now we know the algorithm that when we insert any node in this tree, the size field need to be changed by 1. So means this 8, this becomes 9, this becomes 3, this becomes 2, and this becomes 1. And the left subtree remains unaffected, so let us leave it like this. It will not going to change, neither in terms of key value, neither in terms of structure, neither in terms of size. Now this is the status that we get after inserting node 15. Let me write the colors. This is black, this is black, this is red, and this is also red, because every node that we insert must be red in color. Now if you look at this, this is does not fulfilling the arbitrary property, because the red node has a red parent, and we already discussed how to insert any node in arbitrary. This is case 3 of arbitrary. So if you don't remember the cases of arbitrary, I advise you to just go back to the arbitrary insertion, and then you just come back to this exercise. So here this is case 3. Here we have to rotate from here and change the color of these nodes. So when you do this, the structure becomes like this: 9, this becomes 13, this becomes 10, this becomes 15. Now, this remains unaffected 9. The size of this node is 9. Only the node that is being uh, directly impacted by the rotation is this node and this node. Now, how to fix the size? We are using this thing. So this is actually left rotate, left rotate. This is the case. So this size, this is going to take the place of this. So when this goes up, the size of 13 becomes 3. So the size of this is 3. And what about the size of 10? That 10 goes down. So size of 10 will be the size of left, which is 0. The size of left of this 0 plus 1. That means the size of this will be 1. And this is only 1. So now this is how the tree will took a new shape. And this is not done. We have to also change the color. So this 10 becomes red, 13 becomes black, and this is already red. Now this is our new order statistics tree. Means this is the shape that we get after inserting a node 15 in our order statistics tree, and we have also maintained the size field. Let us take one more example. Okay, now let's insert 4 in this tree. So how to insert 4? So let me first write the status of size here. This is 1. Now we are inserting 4. So how to insert 4? So insert 4, when you do, we have to compare with the 9. 4 is less than 9, so we have to move to the left subtree. Right subtree remain unaffected, so we just leave this as a triangle. That means this tree is by this represented by this triangle. So we'll move down, and as we move down, we have to also update the size. So this 8 becomes 9. Then you go to the third node. This again we have to insert 4, so we have to make it 6. We move right side. This is 6, so we will move left side, but before moving we will change to 4. Then we move to 5. Now 5 is having size 1, so this becomes 2, and then we will move to left side, and this is the place of the node 4, and the size of this is 1. Now we have to check that this is stable tree or not. That means it is fulfilling the arbitrary property or not. So though this is order statistics tree, but we need to keep in mind that this tree is an augmentation of arbitrary. So it must fulfill all the requirement of arbitrary. So let us check. So if we look to the colors, this is black, this is red. Here also we have two. This is black. Here we have 7. Red color. This is red, and this is red. Because whenever we insert any node, it must be red in color. Now if you look at this, this is not a stable tree, because red node have a red parent, so we have to apply the cases. So here if you look, this is case 1, because the uncle is red in color, means the sibling of the parent is red in color. So how to fix it? We just change the color. So we'll just make it red to black and this black to red. But when we make this red, you will find that now the parent of this node is again a red color. Now this is something again not fulfilling the arbitrary property, so we have to again fix it. So we'll look to which case it is falls into. So this is a kind of zigzag scenario, which is case 2. So in case 2, what is required? We have to rotate uh, from the parent. So the parent will be moving in the anti-clockwise direction. So we'll move like this. So what is going to happen? Uh, the 6 will go up, 3 will come down, and the left child of this become the right child of this. So let us see how the structure will look like. So we have 9, and then this is the right subtree. Now I am not writing the size field. We will write it later. Let me first do the means find the structure that how it will going to rotate, and then we will write this size field. So then 6 will go up, and then 3 will come down, and then this is 7, and the 3 left of 3 is 2, and then this 5 is actually become the right of this, and then this is 4. This is how the rotation will impact the structure. Now let us also look to the impact on size. So just make a note that this is the node that you are going to rotate. So actually we have to take care of this node and this node for fixing the size. The other size remains as it is. So this will remains 9. 7 will remain this 1. Now this is going to up and this will go down. So what is going to happen? This node when goes up, it will take the size of this node, which is 6. So 6 will take the size 6. And what about the 3? 3 is going to come down. So the size of 3 will be the left size of the left, this is which is 2, and the size of the left, which is 1. So 2 plus 1 plus 1, that is 4. Size of this will be 4, and remaining will have the size as it is. So this is what we have got. And what about the color? Color will be, this will be black, 3 will is red, 6 is red, 7 is 7 is black, and 5 is black, 4 is red, and 2 is black. Now if we look to this is again, let me segregate. This is history and this is history. Now if you look to this is again not fulfilling or not stable arbitrary, because again this node is having a red parent, and we know that whenever we have a case 2, it will take you to case 3. This is already we have discussed. But whenever you come across case 2, you will do some rotation, and the next structure is a case 3 shape. So now this is case 3. So in this case, what we have to do? We have to rotate at the grandparent, and we have to swap the colors. Let us see how it will look like. So the 6 will go up, 9 will come down. This is the right tree, and the right of this become the left of this, 7, and then we have 3, we have 2, we have 5, and we have 4. This is how the structure will look like. And then let me write the colors now. So this is going to change the color, right? So 6 is going to become black, 9 is going to become red, and 7 remain the same black, or other remain the same color. 5 is black, 3 is red, and 2 is black. Now look to the size. So other nodes remain the same size, but only this node and this node to be taken care, and we'll see how the size is to be written here. So this remain the same. 5 is 2, this is 1, 7 is 1, this is the entire tree. And what about this? So when 6 goes up, 6 will take the size of this node, which is 9. So 6 will be 9 here, and 9 goes down, and the size for this node will be the size of this right plus size of this right. Means now the right of this is this one, 2. Okay, so 2 plus 1, 3, and plus 1, 4. That means this will take 4. Now let me draw this tree as well. So actually this tree represent, this is actually 10, this is 10, and this is 13, which is 1, this is 2, this is black, and this is red. So this is the final tree that we get, and let me write, this is 4. So now you can check. Now this is our complete tree, and you can see now this is a red black tree. How we can verify? The root is black in color. Every red node has a black child. Okay, red node is black child. And also we look to the black height. So black height is actually 2. In this path we have 2 black nodes. This path also we have 2 black nodes. Here also we have 2 black nodes, and here also we have 2 black nodes. So we checked that all the arbitrary properties have been satisfied. This is a arbitrary, and also this is an order statistics tree. Actually, we are inserting in the order statistics tree, so you can verify that total nodes are 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 here size, and also you can check this is 4 because 1, 2, 3, 4, and this is 4, 1, 2, 3, 4. So we are done with the insertion. So I hope you understood that how to do insertion in order statistics tree. Now in the next video, we'll see how to do deletion. That's all for this video. Thank you very much.